we are going to look at permutations and combinations. You remember when we did our tree diagrams in a previous unit, tree diagrams take a lot. Even with dice, we had to make 6 choices on everything, and you realize that that can get out of control really fast. We need a better way to count, okay? So a permutation is an arrangement of objects in a certain order. Order is important. You know what? Okay, so we're going to look at 2 subjects today, permutations and combinations. Permutations, order is important. So if you, for example, if I said I have 30 kids in class and I'm going to line you up according to your height, tallest to shortest, order would matter, right? The tallest kid couldn't be last. If I just say, hey kids, line up, I'm taking you to Starbucks, then order would not matter, okay? So for permutations, certain order matters, right? Okay, and let's look at it. There's a general one. If it's just a plain old problem and I have an X amount of things, you know, I have 25 books on my shelf, and I say, hey, how many ways can you arrange those books? It's a very easy problem. You just take the number with a factorial. Do y'all remember what a factorial is? A factorial is this symbol right here. It's in your calculator in 2 spots. So let me show you that, right? You can go to alpha window 9. So let's write that down. Alpha window 9. Or if you prefer, you can go to math probability 4. But that's a factorial sign. And what a factorial does is it takes a number and multiplies it by every number before. Like 5 factorial means 5 times 4 times 3 times 2 times 1. But your calculator will do that fast. It's got the button. So let's look at this. 10 teams are competing in the final round of the Olympic 4-person bobsledding competition. How many different ways can the teams finish the competition? Well, there's 10 teams, so they can do it 10 factorial. 10 factorial means 10. Write it down one time so you know what that means. Oh, I went crooked because I ran out of space, okay? But it's 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And it's easy to put in. I'm simply going to write 10, and I need a factorial. So that's alpha window 9. And then I just hit enter, and that tells me how many ways I can do that. It's a lot of ways. Your answers might feel scary in this section because you think they're too big. They're not too big. There are a lot of ways, right? So that is 3,628 or 3,628,800 ways. Different orders I could put to that bobsled team. That's why it's hard to figure out a combination that someone has or a password, right? There's a lot of things you could do. Now we change the question up. Your math today is going to be very easy. You're going to punch a button on a calculator. It's going to spit out an answer. The brainiac part comes, what do I need to type into my calculator? So let's see how this one differs. In how many ways can 3 of the bobsledding teams finish first, second, and third? How is this different? We're looking at first, second, and third place. So we have to type that in a different way. We use what's called permutations, which is NPR. This is the old-fashioned way to write that If you're doing it by hand, you can cancel out your factorials. We have a calculator. So what you do is you look at how many things do you have, right? And then how many do you choose? Right? So how many choices are there and how many are you going to choose? So we have what? We have 10. Where'd they go? We have 10 teams. So I have 10. And how many am I going to pick? I'm going to pick 3. I want to know how many ways could you finish first, second, or third. This is where your thought process comes in, what numbers go on there. Once you have that in, you go find it in your calculator. Again, there's 2 ways. Alpha window 7. So you can go alpha window 7. If your calculator is not updated and you don't have an alpha window 7, you can do it the same way we did the other one, math probability, and this one is going to be 2. Okay, math probability 2. So go ahead and punch that in. Once you do math probability 2, it's going to pop this up with 2 empty little boxes, and you just put in a 10 and a 3. If your calculator is not updated and you have a kind of an older one, you'll type in a 10 first, then you'll go get your math prob 2, and then you'll do the 3. So play with your calculator and see how you do it. Different calculators have a little bit different functionality. Let me know if you need any help getting that typed in. So this is 720 different ways that 3 of the teams can finish first, second, and third. This is 10 things taken 3 at a time because I'm taking those 3 and saying they're going to be in first, second, or third. Does that make sense? It's not bad, right? Did everyone find the buttons on your calculator for your specific calculator and you got it to work? Whether you're updated, not updated? Okay. So let's look at, let's say you have your own band. You're burning a demo CD. You have 12 songs on your computer, but the company that's going to listen to your demo only wants 4. How many different ways can you pick 4 songs out of 12? Well, you have 12 songs, and it says how many orders. If you get the word order, it's a permutation, not a combination. Okay? You only know permutation now, so it's easy, but once you're able to pick from both ways, remember, if order matters, a specific order. All right, punch it in and tell me what you got. Make sure you're punching in so you know if you can get it. Don't write down what I wrote down. I want you to punch it in yourself. Make sure your calculator works, that you've got it or you'll be stuck. Is that pretty easy? So what did we just figure out? If I have a certain number of things and I want to take some of them, how many orders can I make? Right? All right, let's look at words. Sometimes if you're going to put things in order, some things aren't distinguishable for others. For example, if you wanted to put your books in order on your shelf and you had 3 copies of The Great Gatsby, if I switch 2 Great Gatsbys, does that change the order? It doesn't. They're the same thing. So what do you do in that case? Very easy. We'll use words as examples because they're easy to see. So how many letters are in the word Monday? 6 letters. Do any of them repeat? Do you have the same letter twice? No repeats. So these are distinguishable. Every letter's different. So there's 6 letters, so it's 6 factorial. So plug that in. Again, how do you get to the factorial? I like the alpha window, 9, right? You can also do math, prob, and I think it's 4, right? Either way, punch that in and keep writing your calculator instructions. Something I'm doing in my notes is I'm writing all my calculator instructions in green. So if later I need to find those, I don't have to sift through a lot of words. I just go to the green stuff. So you could highlight them, pick a different color. And what do you get for 6 factorial? 720. Now, what if I switch this M with this M? Would that make a new word? Would that make a new order? No, it doesn't make sense, right? These 2 M's are the same. So if that's the case, and some things, these are not distinguishable, one M from another M. So this time I have 5 letters, right? But I have repeats. The M repeats and the I repeats. How many M's are there? How many I's are there? So what you put, you make a fraction. This is going to be 5 factorial. And on the bottom, any letters, numbers, anything that repeats, you put down how many copies you have. So 2 factorial, 2 factorial. That's for the M, that's for the I. If I had 3 letters, I'd have a 3 factorial. So do you remember how to get a fraction in your calculator? Alpha y equals 1, right? So punch that into your calculator. Make sure that you can get it to work. You should get 30 ways. Please don't just write that down. Make sure you can find the fraction. And of course, the alpha window. Not very many ways on this one because the M's are the same thing and the I's are the same thing. Everybody get that? Anybody need calculator help? Okay, what you need? Okay, when you go, okay, alpha window, it's going to be either 7, 8, or 9 today. Do you have those choices? If you don't have those choices, your calculator's not updated, so you'll have to do the math and go over to probability then. Yeah. Different calculators will have different choices, and sometimes there's updates, so make sure you know how your calculator wants you to do it. If you have the option for everything, pick the one you like the best. All right, Tallahassee, how are we going to do that? How many letters? So there's 11 letters in Tallahassee. So I'm going to put 11 factorial. Now, I'm just going to write for my own purpose so I can count how many of each letter are there. Which ones? Okay, how many A's are there? So that's a 3 factorial. How many L's? So that's a 2 factorial, and these are just multiplied. You don't have to say multiply if you just write them. What else? Oh, for the S. Okay, so punch it in like that. Now, do you really need the factorial sign with a 2? 2 factorial is what? 2 times 1. So you really don't have to go to the trouble to type in a factorial with a 2 because 2 factorial is just 2. So practice with your calculator. Go put that in. A lot of ways to rearrange the letters in Tallahassee. So if I gave you these and said you had to write a password, you have 831,600 choices. Is that okay? You feel like you know how to count, know how to enter it in the computer? Not bad? All right then. What if something was in a circle? Let's look at that. If you have objects arranged in a circle, there's 2 different things you might have to do. N-1 if there's no fixed point. For example, if I told 3 of you, sit in a circle and talk about this. There's no fixed point. It would be, if there were 5 of you, it would be 4 factorial ways you could sit. Now, if there's a fixed point, it's now considered linear, kind of goes back to the way it was. If there was a fixed point, so I told 5 students, I want you to sit in a circle, and Ben, you're going to be my first person. Now I have a reference point. Ben is first. Now the order is going to matter differently because Ben isn't part of the combination anymore, or any of the part of the permutation anymore, right? So now we don't have to subtract 1. Let's just look at an example. How many ways can 6 charms be placed on a bracelet that has no clasp? Now I want you to keep in mind this is an object, a little bracelet. So it has no clasp. If a bracelet has no clasp, we don't know where it starts or ends, right? So that would simply be 5 factorial because it's n-1. It's got 6 charms. 6 minus 1 equals 5. Now, if it were 5 kids in a circle, 6 kids in a circle, it would be 5 factorial. But this is a little bracelet. If you have an object like a bracelet or a keychain or some small thing that you could flip over, and it would be the same thing, we have to divide by 2. So this would be for bracelets or keychains. Not say people. No, it's just dividing it by 2. Because if I flip it over, I get a mirror image, so it looks like I'm getting twice as many as I should. If that makes sense. Okay, so if I have a small object like a bracelet or a necklace or a keychain where something is in an order, I have to divide by 2. If I had students sitting in desks, I would not divide by 2 because I'm not going to flip you all over and have you on your head and the desk in the air, right? We don't do that. Okay, now, if it has a clasp and I can open it, or if it were a table and I said Ben is going to be the first person in this, I want Ben to be first, everyone else fill in. Then we just do n factorial. So this bracelet would be 6 factorial. Now, because it's a bracelet, right, I still divide by 2. Anything little in a circular permutation, if it's a bracelet or a keychain, I can't even think of other little things, right? If it's a little thing that you can flip over, then you get the same thing twice, we divide by 2. If it's people or putting cars in a circle to sit and talk or something, whatever you want to do. And so what did you get for an answer? I got 60 and I got 360, right? You could use this if, let's say, you were organizing your wedding table, right? And you have circular tables and you're trying to figure out how many ways can you arrange the people at table 1, at table 2, right? Something like that. Does that make sense with a circle? Basically, if it's when you have a circular permutation, If it's a circle where no one is specified or it opens or it doesn't have a clasp, we have to take 1 minus. So however many people or objects you have, minus 1. If someone's at the head of the table or it has an opening, then we just have n factorial. If it's a small thing like a bracelet or a keychain that could be flipped over, we divide by 2. And just keep that in your notes. This is not a big deal. We're not going to do a million of those, but I just wanted to expose you to it. It's not as important to me as the others. Okay, so we're going to look at the second half of what we're doing now. We were looking at permutations where order matters. Maybe I'm lining you up in order of height. Excuse me. So now we're going to look at combinations. Combinations are where a selection of objects where order is not important. So this probably doesn't apply to words or different things, right? Order is not important. So this time, instead of having NPR, you're going to have NCR. This stands for combination instead of permutation. This is still how many in total, and the R is still how many you want, right? So let's look at some examples. A standard deck of 52 playing cards has 4 suits with 13 different cards in each suit. If the order in which the cards are dealt is not important, when you see that, you know it's a combination versus a permutation. How many different 5-card hands are possible? Okay, how many cards are in a deck? 52. How many are you going to pick in your hand? 5. So there you go. You just type it in. So type that in. And make sure, if you're not a card player, that you familiarize yourself with decks of cards. Statistics problems are very much choose cards because everybody kind of knows those, and you can do a lot of different things with cards. So kind of know what's in a deck of cards. And how many 5-card hands could you get? 2,598,960. That's a lot of hands, right? But order is not important. So if you got a queen, then a jack, it would be counting that different than a jack, than a queen, because they don't care about the order, right? All right, now we're going to get tricky. You have to account for any stipulations they put in, right? Like if you told me you wanted a pair of shoes and I gave you a pair of shoes and you're like, that's not the color I wanted, you needed to tell me I want a pair of red shoes. Then there'll be less to pick from, right? Right? If I were giving you shoes to buy and you said I want red ones, I would only bring out the red ones. So think about that. In how many 5-card hands are all 5 cards of the same color? Okay, so we want the same color. How many colors are there in cards? There's 2, right? There's red and black. So I first have to account for color. I need to get the cards down to 1 color because it says they're going to be the same color. So there are 2 colors available and I want 1 color. So this sets us up for 1 color. So these can get a little bit detailed. You have to really think about what they're asking and you have to make everything come true that they want. Now, what's the other thing that they want? 5 cards in a hand. So if I've set it up to be 1 color, how many cards do I have to pick from? I no longer have 52 cards, right? Because I want them to be all 1 color. So how many cards are there of 1 color? 26. So I have 26. And how many am I going to choose? 5. When you have more than one thing that has to be true, we multiply those together. And you can type it in just like that. Do you see what we're doing? And that's why we're going to practice together next block, because I can ask you all different ways, and it takes a little bit of practice to be like, okay, I got this. Okay, punch that in. Okay, and keep in mind, you have to account for everything. This is my 5-card hand. But I eliminated how many cards I was choosing from. Does that make sense? Let's do, say red. Say that I've decided I want red cards. All right, so I can pick a red card. I want 1 color out of 2 colors, and I need to multiply that by the 5 cards I want that are all red. So my second thing is saying the first qualification that I wanted is true. All right. Any Shakespeare fans? None. Uh-oh. All right. William Shakespeare wrote 38 plays that can be divided into 3 genres. 18 are comedies, 10 are histories, 10 are tragedies, and there's a total of 38 plays. How many different sets of exactly 2 comedies and 1 tragedy can you read? All right. What's the combination of a comedy? How many comedies are there? And how many am I looking for? Easy, right? And now I want a tragedy. How many tragedies are there? Wait, there's 10 tragedies, right? And how many am I looking to read? 1. Now, what does this word mean? Multiply. Right? Anytime you have an and, you multiply, and or means you add. If this said 2 comedies or 1 tragedy, I would be adding them. All right, punch it in. Tell me what you got. Notice this unit will be nice because this section won't have decimals because we're counting how many ways. Can you have 3.5 ways of doing something? You cannot, right? Is that okay? Let me give you a minute to punch those in. Make sure you're actually typing it into your calculator so you get that muscle memory, and you're not working on a test going, wait, how, who, what? Okay, you got it? All righty then. How many different sets of at most 3 plays can you read? What does that mean? If I'm going to read at most 3, am I allowed to read 3? Yes. Would reading 2 qualify me? Would reading 1 qualify? Yes. How about reading none? Yeah, I could read none. So this says at most 3, so that means any 3 or less works, right? Make sure you got your mask on if you're here. So I'm going to have to write these up. How would I read 3 plays? What would that look like? 38 C3, or means what? Plus 2 would be what? 38 C2 plus 38 C1 plus 38 C0. Now there's 2 I want you to type in because you're going to know them and then you won't ever have to do it again. So give me a second here. I want you to type in 38 C0 and tell me what the answer is. Whoops, something. What is the answer to 38 C0? So if you see something with a 0 here, the answer is 1. Don't you want to know that? You don't want to type that in, right? I'm too lazy to type that in. So I'm going to remember that if this says 0, the answer is 1. Because there's only one way to pick none of them, right? And that's to pick none. Now, what is 38C1? Right? So I also want to notice that if there's a 1 right here, this is going to be my answer. I mean, do you really want to plug that in each time? The rest you have to plug in, but if you notice the pattern for these, it saves you the work. So plug those in and make sure you get what I get. I could have typed them in wrong. Who knows? I might have been all hyper. Is that good? We're just going to do one little thing and tie it all together. Then we'll be about done. How are you, the student, going to tell the difference between combinations and permutations? Yes. What word are you looking for that would mean permutation? Order. The word arrangement, how many arrangements and how many orders? Start thinking permutations. How many ways? Or if it's something that it doesn't matter, like on these comedies, doesn't matter what order I read them in, right? I just want to read 3 of them or 5 or however many we pick. Okay, I want to show you something cool and then we'll be done with notes and we'll do a delta math together. You ready? Okay. We're going to go back to a few days ago and look at a tree diagram. Given the top 2, this should say 2, y'all. My W didn't push down. That is a typo, not a wrong spelling. I would be embarrassed if it was. Okay. From a deck of well-shuffled playing cards, I'm going to give you 2 cards, right? I got a deck. I'm going to say, here's 1. You're going to look at it and I'm going to say, here's 2. So find the probability of 2 aces. All right. So here's a card, right? And I take the card and it's either ace or not ace, right? Now I'm going to give you a second card and it's either going to be ace or not ace. No matter what you picked the first time, the second card will either be ace or not ace. So let's fill in the probabilities. If you pull a card out from a deck, what's the probability that you get an ace? 4 out of 52. What's the probability you don't get an ace? 48 out of 52, correct? All right, you got your 2 cards. Now, if you got an ace the first time, what's the probability you get an ace the second time? Well, 1 ace is gone, so I'm down to 3. 1 is gone from the deck. I'm down to 53. What's the probability if I got an ace the first time that I get a not ace the second time? Oh, yes. What did I do? Now, the second time, I have 51 cards. What's the probability I don't get an ace? Still 48 because I got an ace the first time. Now, if I don't get an ace the first time, I already pulled 1 ace out, so I still have 48 non-aces left. Remember, there's 4 aces in a deck and 48 non-aces. Kings, queens, 2s, 3s, 4s, whatever you've got. Now, if I pull my first card out and it's not an ace, what's the probability that I get an ace the next time? 4 out of 51. If I do get a not ace, let's say it's a king, the first time, what's the probability that I don't get an ace the second time? 47 out of 51. Now, what question are they asking you? Find the probability of 2 aces. So 2 aces would be this branch here, right? What is the probability that I get 2 aces? Well, remember when we have a tree diagram, we multiply our branches. So that's 4 out of 52 times 3 out of 51. What do you get when you multiply those? Check it out, see what you get. I get 1 out of 221 or 0.00. Make sure that you get this with your calculator. If you come up and say, how do you type that in later? I'm going to say, wait a minute, we did that. Why are you asking me now? Not very high, right? Your probability of getting 2 aces is not real good. You're used to tree diagrams. You've been doing those a long time. That's nothing new. We're also going to compare what would that look like with a permutation or combination. If we do it with permutations or combinations, do you predict you'll get the same answer? You mean you think you can get the same answer doing it 3 different ways? Now I have you worried, don't I? Let's see. All right. Before we do this permutation, because it's going to be a little bit different, tell me in English words, plain words, what is probability? Probability of an event is what? It's what you want or the things you're interested in, like blue marbles, green marbles, aces, over total, right? It's always what you're looking for out of the total. If I said, what's the probability I pick a student in my classroom in a red shirt today? Well, I would say there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 kids in person and 2 have red shirts on. So I'd say my probability of picking a student in a red shirt is 2 out of 11. Probability of picking a student in a blue shirt is 1 out of 11, right? There's only 1 here. So probability is always the topic you're interested in over the how many are there. So let's look at this. What are we interested in here? 2 aces, you said? 2 aces. So with a permutation, how would you get 2 aces? How many aces are available? 4. How many are you interested in? 2. So this is how we get aces. And what's the total in my deck? 52. And I'm going to pick 2. Do you see how you can get probability using, we've been counting, but now we can also get probability. So you just do the P form of what you're looking for over the total. Punch that in and tell me what you get. I think you'll be surprised. And y'all make sure you're keeping your mask up unless you want to build a nice fish tank like I have. What do you get? Punch it in. I should see the little line. See how fast y'all text. I know you can be like, did you get the same answer? You did. If you got a different answer, something would be wrong. It would be a broken system, right? Because the probability doesn't change just because you're using other forms. What do you think a combination is going to be now? What's going to go on top? 4C2, because I want 4. I want aces. There's 4 of them. And I'm going to choose 2 cards. How many total do I have? Out of a total of 52 cards. And I'm still choosing 2 of them. Try it with a combination. Tell me what you got. Did it work? Did you get the same answer? Yes, you did. So why? How can a permutation and a combination possibly give you the right answer? Because probability is a proportion, right? So you have so many choices here out of so many choices. It's going to be the same probability that you pick it because both numbers will change, but the ratio is not going to. So when you're looking for probability now, you have 3 choices. You can do a tree diagram, You can use permutations or combinations. Isn't that kind of cool? All right, we're going to work on some work. I'm going to click this off. If you're listening, I hope this made sense and have a great day.